Are you ready to take your programming skills to the next level? Or you want to get your dream IT job in software development? Introducing the complete C# programming masterclass. Welcome, programmers. In this comprehensive masterclass, we dive deep into the world of C# programming. Hi, my name is Imran Afzal, and I've been in IT for over 20 years. I have been teaching IT-related courses for a while and have over 1 million students worldwide. I teach some of the best-selling and highest-rated courses. I earned my bachelor's in CIS from Baruch College, City University of New York, and my MBA from New York Institute of Technology. By the end of this course, you will have the skills and confidence to tackle any C# project with ease. We will spend a significant amount of time where you will learn all C# tools with practical, real-life examples. Folks, I am telling you, don't miss out on this opportunity to become a C# expert. So let's go learn something together.
Hey folks, I request you to please spend a few minutes with me to know exactly what you're going to learn in this entire course. I have broken down this entire course in 20 different sections and 3 different levels: beginning, intermediate, and advanced. It also includes quizzes as well as exercises. Starting with the beginning level section 1, which is about the introduction. We'll go through the computer languages and what are the different type of computer languages out there before you actually jump into C sharp. Then we will get into object oriented programming. Why do we use that? What's the difference between regular programming and object oriented programming? Then we'll talk about programming application examples, like what are the applications that are built using all these different type of programming languages and codes. Then we have an introduction to C sharp, and finally we'll wrap it up how to succeed as a C sharp developer. Then we'll jump into section 2, where we'll design our lab. This is where the fun begins. So together we will design the lab and do the installation of .NET SDK Visual Studio in Windows. Okay, then moving on to section 3, which is the programming basics. We will start writing a simple program using Notepad. We will output the words hello world, which is a very small basic program. Then getting into C sharp variables and expression types in C sharp, naming convention, primitive data, and types. Naming conventions, keywords, character versus string, typecasting, and string manipulation. All right, then comes section 4. In this section, we'll start with C sharp programming standards and C sharp program structure. Then we'll talk about many important operators like arithmetic and logical operators, as well as simple conditional statements in which these operators are used. Okay, then getting into section 5. Decision making. Here we will cover more deeply if-else statements, ladder if-else statement, nested if-else statement, switch statements, and their exercises. Coming to section 6, methods and exception handling. We will cover all types of methods, exception handling, and debugging techniques, as well as their exercises. Then section 7, where we will go through all types of loops like for loop, while, do while, and nested loops. Moving on to section 8, we'll go through classes and objects, properties, fields, and methods, constructors and deconstructors, access modifiers, and encapsulations. Then comes section 9, collections in C sharp. It's all about arrays, lists, dictionaries, stacks, and queues and their exercises. Then we start with intermediate level. This level starts from section 10, advanced object-oriented programming concepts. So in this, we'll cover inheritance and polymorphism concepts. In section 11, we'll cover threads and task parallel library, asynchronous and await and concurrent processes. In section 12, delegates and events. In this, We will learn how delegation works as well as see the event handler and lambda expressions. Coming to section 13, LINQ and data management. It's all about LINQ, LINQ with collections, LINQ to XML, and LINQ to SQL. In section 14, we'll talk about file I/O, input, output, and serialization. Learn about reading and writing to files, serialization and deserialization, working with JSON, XML file format. Then we go to advanced level and it starts from section 15, asynchronous programming and threading, understanding the threads and task parallel library. In section 16, we'll start with databases and entity frameworks. It's all about storing data permanently in the database using ADO.NET framework. Then section 17, building applications. We'll learn about three different applications using C Sharp: console application, desktop application using WPF, and web application using ASP.NET. Then section 18, it's all about testing our code using different testing techniques like NUnit, MS Test, and test-driven development. In section 19, real life application is a practice section where we create three desktop applications: a scientific calculator, volume, and currency converter applications. Beautiful. The last section is about game development using Unity platform. Sweet, which is section 20, named Unity Basic, where we will cover introduction to Unity, installation and interface overview, customizing layout, implementing player movement, physics basic rules, simulating physical bodies, and finally, we'll create a simple player maze explorer game using Unity. Now, I want you to ask yourself, is this the course that you're looking for? I'm telling you, I bet you this course will get you everything you need to know about C Sharp. So let's go ahead and enroll right away. What is computer language? Before we explore the topic of Java programming, first it is very important that we understand what is computer language. Computer does not know any human language. So they don't know English, French, Chinese, or any language for that matter. It only understands zeros and ones. Computer language, that zero and one language, it's called binary. Computer stores all characters as numbers on hard disk because computer don't know what is hello or how are you is. Computer converts that into these numbers, zeros and ones, and that's how it stores that into the hard disk. The process of converting that data into binary code is called encoding. Now, to better understand, let's visualize it. Now, where is that 0 and 1 comes from? Your computer runs on electricity. If you unplug the power or if your battery runs out of your laptop, your computer will shut down, right? So computer to transmits the data, to save that data, it actually uses 0 and 1, and that 0 and 1 concept came from the electricity. 0 means off, and 1 means on. So this I or 1 that you probably see on your switch. If you go to your switch right now, or if you have an older switch, probably newer switch don't have those 0 and 1 anymore. But if you find one in your house, you're gonna look at it closely and you're gonna see 1 on top or at the bottom, depends which country you are in. So the 1 means that turn on. 0 means to turn it off. Similarly, the computer sends or saves the data on the computer or transfer the data through these zeros and ones. Now, moving on, let's put it in an example of how it could translate a word into zeros and ones. There is a chart that's called a binary chord chart. Each letter that we have has a number or a binary number associated with it. So like A has 1000001, B has 10000010, and so on. So now let's say if you type it in hello on your keyboard. Now, how your operating system or your computer is going to translate that into its processor or memory that, hey, this hello means these digits, so process it. So the first thing it will do is will take the first character, which is H. And by looking at the chart, you will see the H translates to 10001000, meaning on, on, off. Same thing, E translate to 10000101. L, L, and O, O 1001111. So that's like a cheat sheet the computer has, and computer knows that when the letter H comes in or E comes in, I'm gonna have to translate into binary. And again, the binary is on and off. So when the computer puts all these numbers together, it actually sends these signals as on off, on off, on off, on off, and that's how it actually move the data from one computer to another or from your keyboard to the hard disk. I hope now you have a better understanding of computer language. You might be wondering why programming languages like Java, Python, Ruby, and so on are necessary if computer already has its native binary language. That's an excellent question. Now, allow me to clarify one thing. It is indeed possible to write programming code directly in binary language, but it would be very tedious and time consuming. The reason we use these programming languages is that they enable us to write code in a manner that is more accessible for humans to understand, debug, and of course troubleshoot in case there is an issue. So ultimately, regardless of the programming language that you use, the code you write is executed by the computer hardware in the form of binary instructions. In addition, binary language is commonly known as low level language, while other programming languages are referred to as high level languages. It is important to note that the term low or high level do not imply any kind of ranking. Binary language is considered low level because it directly interacts with the computer hardware, while the other programming languages operate on top of it. When a higher level language communicates with a computer, there is an intermediary component that translates it into machine or binary language. This essential bridge that you see, that middle piece between them, is known as a compiler software. So, I hope this clarifies the concept of a computer's native language and why we utilize other programming languages. In the next video, we will cover some of the commonly used programming languages available. Types of programming languages. In this lecture, we will provide an explanation of the various types of programming languages. As discussed previously, programming languages are commonly categorized into two types: low level and high level. Low level languages are designed to be understood directly by the machine and executed by the CPU. On the other hand, high level languages are more user friendly and resemble human language. By utilizing these high level languages, programmers can write code more efficiently and effectively, reducing errors and saving time. Also, high level languages are designed to be closer to natural language and allow programmers to express their intentions. So, coming back to the topic, there are various types of programming languages, each designed with different purposes and applications in mind. Here are some of the main categories. First one is procedural programming languages. In procedure programming languages, a program is divided into a series of procedures or functions that are executed in a sequential manner. These procedures contain a series of instructions that are performed step by step to solve a problem or complete a task. Examples include C, Pascal, and Fortran. The next one is object-oriented programming language, which is the primary focus of our course. The OOP, which is in short of object-oriented programming, organizes the code around objects. Now, what is an object? An object can be anything that you see around you. For example, a table, a chair, a phone, a glass, or even a cat, a game player, or even a button. It describes what a thing is and what it can do. Examples of these languages are like Java, C++, Python, C Sharp, Ruby, PHP, and so on. I will cover the object-oriented programming in more detail in the next video. The next one is functional programming. Functional languages see computation as performing calculations just like a math. They focus on making things unchangeable and avoiding actions that can cause unexpected consequences. Examples include Haskell, Lisp, and Erlang. Then there are scripting languages. These languages are designed for scripting and automation tasks. They are often understood and processed as they are read, and they can handle different types of data without strict rules. Examples include Bash, shell scripting, or C shell, JavaScript, Perl, Ruby, and so on. Then going to the next one, which is the markup language. These languages are used to define the structure, presentation, and behavior of documents. They are not traditional programming languages, but are essential for web development. And examples of markup languages include HTML, XML, and CSS. Then we have query language. These languages are designed specifically for querying and manipulating database. SQL, which stands for Structured Query Language, is the most well-known example of such language. And there are some other ones, for example, domain-specific language, concurrent programming language, and logic programming languages. Object-oriented programming. In this lecture, we will discuss object-oriented programming in more detail, and I will try my best to explain it in a very simple way. In object-oriented programming, we mainly deal with objects. An object can be anything like a person, place, or a thing. It has a specific structure and can do certain things. If you think about things that are not considered objects, we're talking about entities that don't have a clear shape or form and don't do anything specific. Examples of such non-object entities are emotions like happiness or abstract ideas like freedom. These things are not classified as objects because they don't have a physical structure and don't show actions in the same way as concrete objects do. Let me explain you the object-oriented programming through an example. Going back to the basics of programming, which is the procedural or sequential programming. In this type of programming, you write a code in a sequence, right? For example, we want to write a code which will have a set of instructions, and for that, we will use an example of driving a car and pick up groceries. So the code will look something like this. Unlock the car, start the car, check your rear view and side view mirrors, fasten your seatbelt, then of course drive to the nearest grocery store, buy a loaf of bread and a dozen eggs, and of course come back to your car and unlock the car, start the car, check your rear view and side view mirrors, fasten your seatbelt, and then drive back home. Now, if you notice that actions 1, 2, and 3, 4 are similar to actions 7, 8, 9, and 10. Imagine if you have to stop off at another store as well, then you are repeating these steps again and again, which is, of course, not efficient. So, what we do is we define an object and its functions in something we call a class. So, it will be something like class of an object, and the object will be the car. So, for example, we define car as an object and its class that will have functions of unlock the car, start the car, check your rear view and side view mirrors, fasten your seatbelt. Now, if we write our code again, it will become a lot easier to manage. Look at that. Object is the car, then, of course, drive to the nearest grocery store, buy a loaf of bread and dozen eggs. Then again, define object, which is the car, and drive back home. You see, now our code suddenly became from 11 lines to 5 lines. See, that's why the object oriented programming became so popular. So, object oriented programming is a way of writing computer programs that focuses on organizing and managing data by grouping it together with the code that operates on the data. Or in simple word, it treats everything in a program as objects that have their own unique characteristics and behaviors. It helped programmers to create modular and reusable code by breaking down the program into smaller, self contained objects that interact with each other. Just like we created the car as an object which has its own smaller self contained program. This approach allows for easier understanding, maintenance, and of course, expansion of your program. So I hope this example that I have given you is enough and clear enough to make you understand what is an object and why we use object oriented programming when we write a program. So far, we have learned all the different type of programming languages. Now let's spend some time to understand which language is best suited for which application. I want to start off with C++. C++ is a powerful and versatile programming language that was developed as an extension of C programming language. It was created in the late 1970s with the intention of adding object-oriented programming features. All right, so let's take a few examples of C++ applications that are available today. The very first one is the operating systems. Yes, most of the operating systems that you use or build on your computers nowadays are built using C++, and examples are like Windows, Mac OS, and Linux. Then there are many games that are built using C++, such as Grand Auto Theft, The Witcher, World of Warcraft, Doom, League of Legends. Moving on to graphics and multimedia applications, such as Adobe, Autodesk, Blender, and DirectX. Then there are financial systems that are built using C++. Some of them are like trading systems, risk management software. Then there are database management systems that uses C++ language. And those database management system examples are like MySQL, PostgreSQL, and MongoDB. And then the embedded systems are also built using C++, and those systems are automotive systems, medical devices, and smart home automation. All right, that's about C++. Now let's talk about our main focus of the course, Java. Java is programming language that can run on different computer systems without needing changes. Examples of Java applications are big business software such as customer relation management system, human resources management system, supply chain, and so on. Also, Java is heavily used on websites such as banking system, e-commerce platform, content management system. Mobile apps are also built using Java, primarily in Android. Mobile apps examples are WhatsApp, Facebook, Instagram, Spotify, Airbnb, Uber, and the list keep goes on. Then other applications such as scientific applications are used or are built using Java. And examples are image analysis, processing, computational chemistry, bioinformatics, astronomy, and so on. Then, not to forget the games. There are many games that are built using Java, such as Minecraft, Runescape, and many other puzzle and game or card games that are used using Java language. All right. The next one is Python, which is easy to learn and understand. Example of Python applications are web development. Now you probably notice web development is something that can be done using many different languages. It depends the purpose of your website. You could use different languages to build it. The examples of Python web applications are Instagram, Pinterest, Dropbox, and Reddit. Data analysis and visualization is another form of application that is built using Python, and examples are Jupyter Notebook, Pandas Data Frame, Seaboard. Then moving on, machine learning and artificial intelligence applications are built using Python, and some of them are image classification, virtual assistant, healthcare applications. Moving on to the list of applications using Python is scientific computing. Then we have automation and scripting application. We also have desktop GUI application that can be built using Python, and examples of those GUI applications are like calculator, text editor, music player, spreadsheets, and so on. All right, then not to forget games. Game development can be done using Python as well. And the example of games are Snake Game, Tic-Tac-Toe, Hangman, Sudoku, and many other applications. Then moving on to C Sharp. While C Sharp is a programming language made by Microsoft, it is used to create different type of applications such as Windows desktop application, like text editor, media player, file compression. Then there are web applications such as e-commerce website, real estate listing platforms, booking and reservation system, online learning management system. Other applications are like mobile application, which are fitness tracking, expense tracking, news feed, task manager. Then games, 2D platformer, racing games, adventure simulation games can be built using C Sharp. Then moving on to Ruby. All right, Ruby is a dynamic object-oriented programming language known for its simplicity and readability. Examples of Ruby applications are web applications mainly used for social networking websites, online marketplaces, and blogging platform. Then we use command line tools or we build command line tools using Ruby. And those tools are like backup utility, password generator, network monitoring tools. Then there are automation scripts that are built using Ruby, mainly used within the operating system for tasks such as scheduler, database maintenance, deployment. Then other applications are like testing and quality insurance. And the last one, and not to forget the most famous one that is coming nowadays, really famous, are the chatbots. Those chatbots used for customer support, travel assistance, job search, and language learning. So now I'm sure you understand why we have so many different programming languages and which one is best suited for your needs. In this lecture, our focus will be on understanding the distinction between a computer programmer and a software developer. We will explore the unique roles and responsibilities associated with each profession. A computer programmer is defined as a person who has expertise in programming languages and uses such languages to create code for applications. Additionally, they might help write tests for these applications. A software development, on the other hand, is more involved in the application design. They spend a lot of effort ensuring the usability and behavior of the application, including how users interact with it, the application flow, and its accessibility. Software developers frequently collaborate with clients to fully grasp their needs and choose the best possible solution to include into the application. The primary focus of a software developer is to prioritize understanding the customer needs and finding effective solution to address those needs. They place a strong emphasis on creating user-friendly application that effectively solve customers' problem. Let's consider a scenario where ABC Bank is well-established financial institution, recognizes the increasing demand for mobile banking services among its customer base. To meet this demand and provide customers with convenient and secure access to their account, ABC Bank decides to develop a mobile banking application. The project begins with a team of software developers in this scenario. They work closely with ABC Bank's product managers, business analysts, and user experience designers. They conduct a user research, gather insights, and analyze customer needs and expectations for that mobile banking application. Based on the information, the software developers create wireframes and design mockups of the application user interface. They focus on designing an intuitive and visually appealing interface, ensuring easy navigation and smooth user interaction. They incorporate user-friendly features such as Touch ID or facial recognition for quick and secure authentication, as well as options for personalized notification and account alerts. Throughout the development process, software developers maintain a constant feedback loop with stakeholders and customers, conducting usability, testing sessions, and gathering feedback to iterate and improve the application's design and functionality. They prioritize understanding customer needs, designing a user friendly interface, and ensuring an optimal user experience. While the computer programmers in this scenario collaborate with the bank's IT department, software architects, and software developers, they are proficient in programming languages. Their primary responsibility is to implement the technical requirements and architecture defined by the team. The programmers start by creating an authentication module, enabling users to securely log into their accounts. They implement encryption protocols and establish secure connections with the bank servers to safeguard sensitive information. They then focus on developing the core functionalities of the mobile banking application, such as displaying account balances, transaction histories, and e-statements, as well as integrating secure payment gateways for fund transfers. They ensure that the application adheres to industry standards and best practices to mitigate security risk. The computer programmers also work closely with quality assurance team to write comprehensive test cases and conduct rigorous testing, including functional and security testings. They prioritize the technical implementation of the application's features, ensuring reliability and accuracy. The computer programmer specialized in writing a code and implementing software functionality, focuses on programming languages, algorithms, and problem solving. And that is well suited for individuals who enjoy technical aspects of coding and have a strong aptitude for logic and problem solving. While software developer has a broader scope, involved in multiple aspects of software development, works on requirement analysis, system design, testing, collaboration, and documentation. Ultimately, the best role depends on your personal preference, strength, and career goals. I hope you learned something useful in this lecture, and I'll see you in the next one. Hey folks, in this lecture we will cover the introduction to C Sharp. C Sharp is written as C with a hash sign and pronounced as C sharp. C sharp is a programming language developed by Microsoft that runs on the .NET framework. It is an object oriented programming language developed by Microsoft. C sharp has its roots in the C family of languages, sharing similarities with C++ and Java. Therefore, it makes it easy for programmers to switch to C sharp or vice versa. C sharp is used to develop web apps, desktop apps, mobile apps, games, and much more. By running on the .NET framework, providing a strong environment for development. With the .NET Core and a later .NET 5 and beyond, C Sharp applications can run on multiple platforms, including Windows, Mac OS, and Linux as well. The first version of C Sharp was released in 2000, making it beginning as a modern programming language. Now, over the year, C Sharp has evolved with the new features and enhancement, aligning it with the needs of developers and industry trends. All right, its syntax is expressive and easy to understand, making it a popular choice for developing various types of applications. It offers strong type safety, helping developers catch errors at compile time rather than runtime. Okay, moving on, C Sharp utilizes automatic memory management, relieving developers from the burden of manual memory management. Beautiful. C Sharp integrates smoothly with other Microsoft technologies as well, such as Azure Cloud Services and SQL Server databases, which of course we'll cover later on. Microsoft offers powerful development tools like Visual Studio and Visual Studio Code tailored for C Sharp development. These tools provide a plethora of features, including debugging, code refactoring, and IntelliSense, enhancing productivity and code quality. I hope you learned something useful in this introduction to C Sharp, and I'll see you in the next lecture. History of C Sharp. In this lecture, we will go over the history of C Sharp. The story of C Sharp starts in the late 1990s when Microsoft wanted to solve problems in making software and use new technologies. It's a myth that the development of C Sharp started by Microsoft being inspired by the C language simply because of its first letter, which is, of course, a C. In fact, Microsoft drew inspiration from Java, not C, for the development of C Sharp. Therefore, its design and syntax are more closely aligned with Java. Java's widespread success was due to its simplicity, object oriented features, and ability to run on different platforms. Recognizing this success, Microsoft decided to create their own language, C Sharp, with similar capabilities to compete with Java. The reason behind the development of C Sharp by Microsoft is to be a modern, easy to use programming language that works well with the .NET framework. Smart. They wanted to fix problems in other languages like C++ and Visual Basic. They aimed to make it fast, safer, and better for building all kinds of apps, like ones for the web and businesses. The initial development of C Sharp began within Microsoft Developer Division, led by Andreas Heilsberg, a famous Danish computer scientist known for his work on Turbo, Pascal, and Delphi. They created C Sharp while also making the .NET framework, which helps build and run programs on Windows. The initial development of C Sharp took approximately 18 months. So, the Andres Heilsberg played a central role in the invention and development of C Sharp. He, along with his team at Microsoft, worked tirelessly to design and refine the language. C Sharp was first released to the public as part of the Microsoft Visual Studio .NET Beta 1 program in 2000. Since then, it has become one of the most widely used programming languages in the world, particularly for building Windows applications, web applications, and enterprise softwares. All right, this is about the history of C Sharp, and I'll see you in the next lecture. In this lecture, we will explore the origins of the name C Sharp and the reasoning behind Microsoft's choice for naming its programming language. So the name C Sharp for the programming language developed by the Microsoft is very clever play on a musical notation and the heritage of the C programming language. Here's a breakdown. In music, the sharp symbol, which is the pound or hash, denotes that the pitch of a note is raised by a half step. The use of the sharp symbol in C sharp symbolically indicates that the language is a higher or sharper version of C, implying enhancement or advancement. Now that's smart. Okay, now let's go over the relation of C sharp with the C and C++ programming languages. C sharp is conceptually related to C programming language and its object-oriented successor C++. The idea is that C sharp is a step beyond C++, just as the note C sharp or C pound is one half step higher than the note C in music. In fact, C++ itself was named to suggest it was an incremental improvement over C, as plus plus is the increment operator in C and C++ programming languages. Let's look at the pronunciation and representation. In the context of programming, the pound or hash symbol is easier to display and type on the standard keyboard than the actual sharp symbol used in musical notation. So C sharp is pronounced C sharp, drawing the connection to the musical sharp. But for practicality, the hash or the pound sign is used in writing. This naming convention reflects a trend in computer science to use creative and meaningful names for programming languages, often with puns, references, or symbolism to convey the language's characteristics or lineage. Okay, now I hope you learned something useful in this lecture, and I'll see you in the next one. Hey folks, in this lecture, we will explore the benefits of working with C Sharp. The first benefit of C Sharp is it's easy of learning because C Sharp has simple and readable syntax, making it beginner friendly. Then cross-platform development. Developers can use a C Sharp to build applications for Windows, Linux, and Mac OS. Next one is built-in security. C Sharp provides features to help developers write secure code, reducing vulnerabilities. All right. The next benefit is a large community. So there is a big community of C Sharp developers. So finding help and resources is a lot easier. All right. Now we're going to talk about the scalability. C Sharp is suitable for both small project and the large scale enterprise applications as well. Then the modern features. It's regularly updated with new features and improvements to keep up with modern development needs. Okay, now next one is the object-oriented programming. C Sharp follows object-oriented programming principle, which makes code organization a lot easier. All right, moving on to the next one, which is support for asynchronous programming. C Sharp makes it easy to handle tasks that run asynchronously, means performing tasks independently of the main program flow, allowing other operations to continue while waiting for a response or completion of the asynchronous tasks. Finally, the main benefit of C Sharp is its versatility. because it allows developers to build a wide range of applications from desktop software to web applications, mobile applications, and even games, all within a single language and ecosystem. Okay, I hope you learned something useful about the advantages or benefits of C Sharp, and I'll see you in the next one. In this lecture, we will explore what can be built using C Sharp programming language. So, as we discussed in the previous lecture, that the main benefit of C Sharp is its versatility because it allows developers to build a wide range of applications from desktop software to web applications, mobile apps, and even games, all within a single language and ecosystem, remember? So, we will start with desktop application development. By using C Sharp, we can create desktop applications for Windows computers. With frameworks like Windows Presentation Foundation, in short WPF, or Windows Forms, we can design built in user interfaces, in short UIs, that provide easy navigation and interaction for users. Next one is web application development. C Sharp is widely used for developing dynamic web applications and web services with ASP.NET. ASP.NET provides a robust framework for building web applications that are scalable, secure, and efficient. We can create interactive web pages, web APIs, and server side logic to handle requests and process the data. ASP.NET also supports various web technologies like HTML, CSS, and JavaScript, enabling the development of modern and responsive web experiences. Then, mobile apps development. Xamarin allows to develop cross-platform mobile application using C Sharp. With Xamarin, we can write code once and deploy it on multiple platforms, including iOS, Android, and Windows Phone. This significantly reduces development time and effort compared to building separate native apps for each platform. All right, then the last one is game development, which is, of course, for some is one of the first priority that what they can build using C Sharp. C Sharp is extensively used in game development, especially with frameworks like Unity. Unity is a powerful game engine that supports both 2D and 3D game development across various platforms, including PC, consoles, mobile devices, and AR VR devices. With Unity and C Sharp, we can create visually stunning graphics, immersive gameplay, mechanics, and engaging gaming experiences. Now, please note, we will create applications and games, all of them, in this entire course. All right. So that's about this lecture, and I will see you in the next lecture. In this lecture, we are going to discuss how to succeed as a C Sharp developer. This is a great question you should ask yourself if you want to become a C Sharp programmer. One of the primary reasons to consider learning C Sharp is its extensive adoption by top companies with history spanning over 20 years. C Sharp has established itself as stable and reliable programming languages favored by prominent IT corporations. Now, according to StackShare, around 2,500 companies reportedly use C Sharp in their tech stacks, including industry leaders such as Delivery Hero, Accenture, Stack Overflow, Intuitive, and many more. While these companies also utilizes other emerging technologies, but C Sharp remains a key component in their software development ecosystem. It is no surprise that highly trained and skilled C Sharp developers are in high demand with attractive salaries, of course. According to Indeed.com, the average base pay for entry level C Sharp developer is around 150,000 US dollars per year. Sweet, with potential for significant growth as experience and skills increases. Now, salaries can reach up to 200,000 plus per year for experienced C Sharp developers. According to Stack Overflow, that conducted a survey in 2023, C Sharp consistently ranks amongst the most popular programming languages. All right, so now let's get back on the topic how to succeed as a C Sharp developer. It is important to stay up to date with the latest advancement frameworks and best practices through continuous learning. Explore more online resources. There are many online resources where you could get your training, documentation, tutorials, and participate in forums to expand your knowledge. Also, apply your knowledge by working on a real world projects. Then engage with C Sharp community, join developers forum, and participate in open source project. There are many that you will find online. So collaborating with other developers exposes you to diverse perspective, fosters learnings, and helps you stay connected with the latest trends and opportunities. Okay, then familiarize yourself with the powerful C Sharp development tools like Visual Studio, Visual Studio Code, JetBrains Writer, Mono Develop, and many more. Now, these IDEs offers a wide range of features that streamline the development, debugging, and code maintenance, ultimately boosting your productivity. Then, not to forget a right, clean, efficient, and well-structured code. Follow coding conventions, use proper naming conventions, and leverage design patterns to ensure your code is maintainable and scalable. All right. Then another advice is investing time in understanding the core concept of C Sharp, including object oriented programming, inheritance, polymorphism, and exception handling. A strong foundation will empower you to tackle complex projects with confidence, then actively seek feedback from peers, mentors, and experienced developers to enhance your skills. Embrace constructive criticism, learn from your mistakes, and strive for continuous improvement in your coding practices. All right, by following these guidelines and continually refining your skills, you can position yourself for success as a C sharp developer. And I bet you on that. Opening up a world of opportunity for you in a language known for its versatility, industry support, and robustness. All right, folks, I hope you learned something real useful as to becoming successful in C Sharp developer. And I'll see you in the next lecture. Lab design. In this lecture, we'll go through our lab design, the lab in which we will be practicing C Sharp programming language throughout this course. The very first step in our journey is to download and install the .NET SDK on a Windows computer. This important framework will serve as our foundation for holding the process of how C Sharp code transforms from a human readable source code into machine executable code. So, identify what kind of computer you have. Also, make sure you have the available resources for .NET SDK like memory, CPU, and disk space. While installing .NET SDK on Windows, it's important to remember that most modern computers use 64-bit editions of Windows. Therefore, we should install the 64-bit version of .NET SDK to ensure compatibility and take advantage of system's capabilities. To install the .NET SDK on a Windows computer, you must ensure that your system meets certain minimum requirements. The .NET SDK is designed to work on different versions of Windows, including Windows 8, 10, 11, as well as Windows servers 2016, 19, and 2022. You should have at least 4 gig of RAM, which is like your computer's short-term memory, and a processor with the speed of 1 gigahertz or faster. Additionally, you will require some free space on your computer's hard drive to install the .NET SDK and development tools. The exact amount of space required can vary depending on what components you choose to install, but having a few gigabytes of free space should be sufficient. Lastly, having an internet connection is important because you will need it to download the .NET SDK and any related packages during the installation or download process. These requirements ensure that your computer can run the .NET SDK and enable you to start developing software using .NET on Windows. Now we will talk about Visual Studio installation on Windows. This is the tool that we will use throughout the course. Visual Studio is an IDE which provides us the user-friendly interface with tools for writing, editing, and debugging code. Additionally, Visual Studio assists in managing projects, making it easier for developers to create, test, and maintain their software efficiently. If you talk about system requirements for Visual Studio installation on Windows, it's very important to ensure that your computer meets specific minimum requirements. For this, again, Visual Studio requires you to have Windows 10, 11, as well as Windows Server 2016, 19, and 22 as your operating system. Your computer should also have a processor with the speed of at least 1.8 gigahertz, although it is recommended to have a quad core or better processor if you plan to handle more demanding workloads or if you're going to be running this software on corporate level environment. Now, in terms of memory, a minimum of 2 gig of RAM is necessary, but of course, it's strongly recommended to have 8 gig or more for smoother performance. You will also need to make sure you have a minimum of 20 gigabyte of available disk space for Visual Studio and related components. For an even better experience, it's highly recommended to use a solid state drive to enhance performance. Furthermore, an internet connection, as I previously mentioned, is essential since certain features, updates, and third party components depend on internet connectivity during the download and usage of Visual Studio. Next, we will discuss the installation of Unity Game Engine on Windows. This is the tool that we will use for game development. For the installation of Unity software, the system requirements are similar to Visual Studio. But Unity software requires a minimum of 4 gig of RAM. Keep in mind that these system requirements may vary depending on whether you are installing Visual Studio Community, Professional, or Enterprise Edition. So it's a good idea to verify the specific requirements for your chosen edition. All right, folks, I hope you learned something useful in this lecture as well, and I'll see you in the next one. Lab design. In this lecture, we will cover the introduction to the software tools that we will use throughout this course. These tools are .NET SDK, Visual Studio, and Unity. We will address three questions to better understand these tools. The first one is what is .NET SDK and Visual Studio? The second one is why are they important in C# programming? And the third one is why do fresh learners use them? So, first, we will discuss the .NET SDK tool. So, the .NET SDK, which stands for Software Development Kit, is a collection of tools, libraries, and resources provided by Microsoft for developing applications on the .NET platform. It includes everything developers need to create, build, test, and deploy applications using languages like C#. In C# programming, the .NET SDK is important because it provides access to the core libraries and runtime environment necessary for building C# applications. It includes compilers, runtime libraries, and tools for managing dependencies, packaging applications, and debugging. Now, fresh learners often use the .NET SDK because it offers a comprehensive and a well-documented set of tools and resources that streamline the development process. It provides beginners with a structured and standardized environment to learn and practice C sharp programming, allowing them to focus on understanding the language and building applications without worrying about setting up complex development environments or managing dependencies manually. Additionally, the .NET platform's popularity and extensive community support mean that learners can easily find resources, tutorials, and help online as they progress in their C Sharp programming journey. Now, we will discuss Visual Studio. So, Visual Studio is an IDE, which stands for Integrated Development Environment, also created by Microsoft for software development. It provides a comprehensive set of tools and features for writing, debugging, and deploying applications across a variety of platforms, including Windows, Android, iOS, and web. In C Sharp programming, Visual Studio is important because it offers a highly efficient and user friendly environment for writing code and managing projects. It includes advanced code editing features such as IntelliSense and provides context aware suggestion and auto completion, as well as powerful debugging tools like breakpoints and watch windows, which help developers identify and fix errors in their code quickly. Fresh learner often use Visual Studio because it provides intuitive user interface, extensive documentation, and built-in templates, making it easier for beginners to get started with C# development and learn the language effectively. Beautiful. Furthermore, Visual Studio's integration with the .NET SDK and other Microsoft technologies simplifies the process of setting up development environments and managing dependencies, allowing learners to focus on mastering the fundamentals of C# programming without getting bogged down by the complexity of tooling and environment setup. Now, we will discuss a Unity software. So, Unity is a powerful cross platform game engine used for creating interactive 2D and 3D experiences. It's important in C sharp programming because Unity utilizes C sharp as its primary scripting language, offering a familiar environment for developers. Fresh learners find Unity valuable due to its user friendly interface, extensive documentation, and many online resources, enabling rapid skill development in game development. Okay, I hope you learned something useful in this lecture as well, and I will see you in the next one. Installation of .NET SDK. Hey folks, in this lecture we will see how to install and configure .NET SDK on Windows. Before we go to the installation first, we will see what is .NET SDK and why we use it in our course. The .NET SDK, that is a short form of .NET Software Development Kit, is like a toolbox for software developers. It's a collection of tools and resources specifically designed to help developers in building applications that operate on the Microsoft .NET platform. The purpose of installing this framework is to open a window into the world of software development with C Sharp. It lets us have a quick look behind the scene to understand how C Sharp source code functions and transforms into functioning software. So, the .NET SDK will be our gateway to explore and learn the inner workings of the software development using C. To begin the installation of the .NET SDK, open web browser and navigate to the Google search engine. In the search bar, type .NET Microsoft to find the official .NET download page. The first search result should lead you to the official website, which is .NET.microsoft.com. Click on this link to access the download page. On the download page, you will find options for .NET 7.0 and .NET 6.0, both in 64-bit versions. It is advised to select the latest version, which is in this case is .NET 7.0 to ensure you have access to the latest features and improvements. So, click on the download link for .NET 7.0 to initiate the download process. Once the download is complete, click on the downloaded executable file and run it. This action will kickstart the installation process. Upon running the downloaded executable file, you will see the initial installation screen displaying an install button. Click on the install button to kickstart the installation process. As the installation progresses, you will see the status update. Once it's successfully completed, you can now close the installation window. At this point, you have successfully installed the .NET SDK on your computer. Excellent. To confirm whether the .NET SDK is installed on your computer, you can take a quick check. Start by pressing the Windows and R keys simultaneously, which opens the Run dialog. In this dialog, type CMD, which is a command in short, and hit Enter to open the command prompt. Inside the command prompt, simply type .NET and press Enter. If you see information displayed, it means that the .NET SDK has been successfully installed on your system. To configure the command prompt as a C# compiler, you need to add the .NET SDK executable location to your system's environmental variable called path. This allows the command prompt to recognize and run the C# compiler without needing the full path every time you use it. To locate the directory path for the .NET framework, first navigate to your computer's C drive. Inside the C drive, open the Windows folder. Within the folder, look for the folder named Microsoft.NET and open it. Inside the Microsoft.NET folder, you'll find a folder called Framework. Double-click on this folder. Within the Framework folder, you may see different subfolders corresponding to various versions of the .NET Framework. To use the .NET Framework version 4.0, navigate into the version 4.0 folder. At this point, you have reached the directory path that is required. Copy the complete path from the address bar in our File Explorer. Now, set this path in environment variable. For this, search environment variable in the Start menu search bar. Click on Edit the system environment variable. In the System Properties window, click the Environment Variable button. In the Environment Variables window, under the System Variables section, find the Select the Path variable and then click Edit. In the Edit Environment Variable window, click New and paste the directory path here. Click OK to save changes and close all the open windows. Now .NET Framework has successfully configured. All right, beautiful. I hope you learned something useful in the installation of .NET SDK, and I'll see you in the next lecture. Installation of Visual Studio. In this lecture, we'll go through the process of downloading and installation of Visual Studio, the software that is important for writing and developing our programs. So Visual Studio is a powerful integrated development environment, or in short IDE, that provides a user-friendly platform for coding and creating applications. This software will be our primary tool throughout the course, so it's crucial to get it up and running on our computer. During this session, you will walk through the steps required to download and set up Visual Studio on your system. Let's go through the process of finding and downloading Visual Studio. To get started, open your web browser and go to the Google search engine or any search of your choice. In the search bar, simply type Download Visual Studio. When you do this, you will see search results that include options for Visual Studio 2022 and 2019. Here, Visual Studio 2022 is the latest release, and it's important to note that new versions aren't necessarily released every year. There can be gaps between releases. When you click on Search to download the Visual Studio, you will find the official website, visualstudio.microsoft.com. This is where you can download Visual Studio. Click on the link that will take you to the main Visual Studio page. As you scroll down on the main Visual Studio page, your purpose is to locate and access the community version of Visual Studio 2022. Because it's completely free, meaning there are no costs or charges associated with it, it's an ideal choice, especially for those who are just starting with programming or want to explore the capabilities of Visual Studio without any financial commitment. Now click on the Community 2022 option from the list. This action will redirect you to the page where the download process begins. As you click on this option, it will initiate the download of Visual Studio 2022 Community Edition. After downloading, the next step is to run the downloaded file. However, it's important to note that running this file doesn't directly install Visual Studio itself. Instead, it installs the Visual Studio Installer, which is a software tool designed to facilitate the installation of Studio or Visual Studio on your computer. Now go ahead and run this file. When you do that, it will be presented with a screen that will prompt you to click on the Continue button to initiate the installation process. Once the Visual Studio installer is installed, you will either see this screen automatically, or you may need to open it manually if it doesn't pop up automatically. You can select from the available options, and the one I'm going to use is Visual Studio Community. Click on Install. Now you will return to the default screen. On this screen, you will notice a section labeled as Installed, and at this point, it will show that nothing has been installed yet. This is the starting point of your installation journey, and from here, you will be able to select and configure the specific components and features of Visual Studio that you want to install on your system. So there are multiple tabs here, and you are going to go over them step by step. But first of all, let's look at what you have on the workloads. So you can see you have cloud options here or workloads that you can add. For example, ASP.NET, Web Development, Node.js, Python, and Azure. So if you need any of these, you can install them. However, these will be advanced topics that you won't need at the beginning. Desktop and mobile applications will be relevant because you are going to specifically write a WPF applications. So now you go over the individual components tab here. You will find all the components that you can select and deselect. For example, you could even go ahead and install super old .NET Core runtimes such as 3.5 or any other. But the latest one is .NET 6.0. So the naming convention has changed over time. Now select version 6.0 long-term support. So you can obviously install whatever you want from here, but I would recommend you to not just leave the default except for this one setting that I showed you here. Now, if you want to install other language packages, feel free to do so. By default, in my case, English is selected, but you can use any of the given language packages here and install them if you prefer. You can also change the installation location. You can download the cache. You can see where the shared components will be located. This is the default location where our solutions will go when you create a new application. Now, back to the workload tab and check the desktop.NET development option. And let's go ahead and click on install. And this will then install Visual Studio Community 2022. This will take a little while until the installation is complete. You will notice that Start after installation is checked by default. Therefore, Visual Studio Community 2022 will automatically launch once the installation is fully completed. Once the installation of Visual Studio is done, it will ask you to sign in. At this point, you can either proceed to create an account or sign in if you already have an account with Microsoft. Alternatively, you can choose not now, maybe later, and then decide which theme you want to use. I mainly use this theme because I really like it more than other themes. But if you like the default blue theme or the black theme, just go ahead with those ones. In my opinion, the light theme is just better on the eyes if you're using it for a long time. And there you have it. Now you can go ahead and get started by creating a new project, for example. Or you can also continue without code. Now, installation of Visual Studio is complete. You have successfully gone through the steps necessary to set up Visual Studio on your computer. This means that you are all set and ready to start coding and developing your programs using this powerful integrated development environment, in short IDE. Okay, I hope you learned something useful in this lecture as well, and I'll see you in the next one.